U.S. Army Corps of Engineers is responsible for the design, installation, maintenance, and effectiveness of the flood protection system for the greater New Orleans area of South Louisiana. The new flood protection system was built in 2006 following a devastating Hurricane Katrina. One of the main components of the flood protection system are the series of pumps that work to move water during storms. Engineers designed the main components of the pumps out of AISI or SAE 1080 structural carbon steel coated in a layer of coal tar epoxy paint with one sacrificial zinc anode per pump.
The material used for these pipes was AISI or SAE 1080 steel. The microstructure of this steel is fine perlite with a mix of ferrite and cementite phases. The benefits of this microstructure are that it is harder and stronger than coarse perlite, which aided in handling the water pressure from the pumps. It also allowed for greater restriction and dislocation. The cubic structure of this steel is body-centered, where the atoms touch each other along the cube diagonals. This specific type of cubic structure is less ductile but stronger than others. The AISI/SAE 1080 steel properties are that it is low in ductility, high in tensile strength, and high in carbon. Other properties, such as modulus of elasticity, yield strength, and different hardnesses are mentioned in this table.
Unfortunately, South Louisiana is hot, humid, and contains brackish waterways with a mixture of fresh water and salt water. In addition to this, various carbon-consuming organisms live in those waterways. These conditions are particularly harsh on carbon-containing metals and increase chances of corrosion greatly. These are photos of the pumps of the flood protection system after only a few years of installation. The pumps were intended to last 35 years, however, they have corroded and failed after only 5 years of use. The failure of the pump materials resulted in inadequate pumping of water out of residential and commercial areas, leaving the community flooded during storms. Various news reports attribute the rapid corrosion to the harsh brackish marine environment, as well as the organisms that eat away at the carbon-containing metal. Obviously, the zinc anodes and coal tar epoxy paint were not enough to combat the biological and chemical reactions between the carbon steel and its environment. One of the main ways the pumps corroded was through rust. The brackish water and humid environment resulted in redox reactions between the carbon steel and its environment. The failure of the pumps ultimately cost the City of New Orleans and the Army Corps of Engineers over $700 million in damage and repairs. Currently, the Army Corps is still carrying out efforts to fix and repair failing pumps throughout the area. These efforts include completely replacing bearing seals as well as cleaning and recoating other corroded components with the coal tar epoxy paint.
Based on research done by the U.S. Army Corps of Engineers and our own, the proposed solution to replace the ASI 1080 steel pumps is 316L stainless steel. The microstructure of the steel is austenitic. The cubic structure is face-centered, where the atoms touch each other along the face diagonals. This is a soft, ductile, and formable structure. The 316L stainless steel is high in toughness and highly corrosive resistant, specifically for water. This is what makes it the best option to replace the AISI or SAE 1080 steel for the pumps. The elastic modulus is 189 gigapascals. The table here has other properties for the steel type, such as the strengths and the hardnesses. Another benefit to the 316 stainless steel is that it contains less carbon than the AISI SAE 1080 steel. This means that the carbon-consuming organisms in the environment around the pumps will not corrode the new steel as they did the 1080 steel. Therefore, the pumps will last longer than the previous ones.
In conclusion, we believe that the pump should be fully replaced with 316L stainless steel. While the Army Corps is currently making efforts to replace some of the parts of the 1080 structural steel, we believe that the pumps should be fully replaced using the new 316L stainless steel. This way, corrosion will be less likely and failure will be less likely.